I've had a lot of requests to talk about the Carisma GT-24 and the custom electronics I did on it. Your student of you will notice that this is actually not the modified GT-24, but an actual second one. But let's dive in and take a quick look at what I've done electronics-wise and how easy it was to convert over. And through the magic of editing, this will magically transform to the other one. So 1, 2, 3. I mean, this is live after all. Did you actually expect any magical effects? Anyway, getting into it, you can actually see the electronics are, let me put that back on, relatively simple here. Using my standard Ensotech ESCs that I use on a lot of my stuff. Servo underneath here, if I can get it in shot there. And then we've actually got a micro mini Z transmitter, well, NB4 transmitter shoved into there, which only just fits, and you have to get the orientation correct, but once it's in there, it's actually rock solid. The other thing that it's doing that's really, really helpful is making sure that this power cable here is retained. Otherwise, it's loose, and any excessive force on here will actually tug on the ESC, which in itself is not an issue, but it's a very, very good way to break cables. So. Now I did have to plug this into Bluetooth and make some minor changes. I don't know if that was because the ESC was in the default or because I ripped this off another model and I had it in counterclockwise mode. But as soon as I swapped it over to clockwise mode, everything ran fine. There were no real issues. This is a W model. I think it's the original W model, not the second one. So it is a 20 amp ESC. There hasn't been a lot of information on what the current draw of this little car is, but that seemed to do pretty well. Gear mesh is alright. So the other thing is I've kept the original cable there, so it's quite easy to disconnect and replace, which is going to be good because I'd like to actually change the gearing here and give it a bit more acceleration and a bit more torque, just to be able to get the back end out a bit quicker. I mean, the motor is pretty capable like that anyway, but also dropping down to a lower, to more acceleration and torque heavy gearing will give me a bit better battery life and reduce the current draw a bit. I'm still a bit worried about the current draw of this motor. It seems fine. In fact, it seems a lot peppier with this ESC than the last one. But you can never be too sure. One of the nice things is I can go from reverse to forward and forward to reverse significantly quicker with this. And from 0 to full acceleration a lot quicker. With the standard Carisma GT ESC, there was a noticeable delay if you're trying to do anything quick. And if you're trying to do any Gymkhana or quick rotation stuff, it was very, very noticeable. Other things to note, I've got the Mini Z pinstripe tyres here. They only just fit on the back, and on the front they fit fine. They're all relatively loose. I've greased up the rear and front diff. The front diff is a slightly grippier compound or grippier grease than the rear. I did try swapping them. I honestly can't tell the difference. It takes so long to swap them back and forth that by the time you've swapped them back and forth, it's hard to, very, very difficult to determine what the performance was like before and what the difference is. So not much you can do about that. But having the stronger grease oil on the front is useful because one of the things this car does is in the turns, as anyone who has one of these will probably know, it tends to lift the front tyre here. So it'll rotate onto these 3 tyres. And if the diff is open, you lose all power over here. And if you're turned in like that, that can actually lead to rolling the vehicle. The grease helps a bit. These tyres help even more because these tyres slip side to side a lot more than the standard Carisma tyres, which are super grippy. Let's see if we've got an example here. As you can see here. These tyres are really, 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 like they're a soft rubber. On dirt or dusty trails, these are great, but on anything else, anything with even the slightest bit of grip, these are much, much better tyres. And on carpet, these are significantly better. So we've gone over the ESC. As you can see, I've sort of just jammed it in here, and I've had to be very, very careful that the electronics don't short on the motor case. That's just being held down by double-sided tape. I would actually put some double-sided tape under there if it was a concern. We've got the receiver with telemetry. We've got the rear, I probably didn't go into detail on this enough, the rear, I can't remember what it's called, the slipper clutch, that's the one. Now, the only modification I've made to the slipper clutch is I have a sheet of neoprene, and I have put a really, really thin layer of neoprene in there, just so that it doesn't click at all. I wonder if I can make it. Yeah, you probably can't. It means that when it's slipping, you can't actually hear it clicking, but the other reason I did it was it also tightened up the slipper clutch a bit, which has allowed me to get a bit more torque out of it, which has been really, really, really nice. All these modifications have sort of modified or twisted the frame slightly, so the battery case does have a bit of trouble getting on. It's very, very minor, but getting the battery case on and off is, not being able to come on and off is really, really annoying. Now, probably the more important part is how I did the servo. Now, I get a lot of questions about this. Let me just see if I can find my pointer. There we go, and actually I'll use a cotton bud because it's white. I did do a lot of work on here to make the contrast of the black on black stand out, so you can actually see a lot of the details of the chassis, which was worked out rather nicely, all in all. So if we go like that, you can see we've got one of these servos here. Now these servos are just the purple special I use for everything, the AGL, can I get a shot? Yeah, the A11 CLS. I just bought these off Banggood. I think they are the V2s, not V3s. You can see here I've got a custom shoehorn in here with the screw that came with the servo. And then if you look very, very carefully, you'll notice that there's a very, very, very long rod here. Now all that is actually just a really, really long screw, but the one thing to note is that the space from the servo to the actual steering mount is actually very, very long. So the first couple of screws I reached for were actually not long enough, so when you're doing this, make sure you've got a long one that's long enough. Now the funny thing is that the servo I mentioned earlier bolts right in, well almost bolts right in, it fits. It's the right height vertically. I'm using the original retaining case. The only thing I have done on it was I did have to shave down this little arm bit, a couple of mils, right down to, you can see there's a little hole behind it. I had to shave it all the way down to where the hole just became a gap, and it was relatively easy to fit in there once I did that. I did it on both sides. You don't have to worry about doing too much, you just have to worry about doing too little. So I used a diamond file, and then the diamond file was a bit too coarse and wasn't cutting enough, so I just used a standard steel file, tool steel file, and that worked really, really well. The hardest part is holding the servo as you're going over the file. Let me just grab the file. So I was using, this is one of the diamond files. I was holding it like this and going like that. You can see how thin this file is. It's very, very easy to slip off. So you either get really, really complex hand maneuvers to hold everything in place, or honestly just get a wider file and do it on that. It'll save you a lot of time. It doesn't take very, very long. This is actually very, very soft metal. The only issue is you have to find the correct, something that's not too aggressive, but aggressive enough. So play with a couple of files and see what shaves stuff off. Once you've got some of the wings off slightly, it'll slide right in. Although honestly, on the right hand side, you probably do want to keep a bit of that there and be very, very careful with that, because this one mates against the outside of the body and it's actually crucial for keeping the servo in position. The left hand side one actually touches the drive shaft going down the center of the chassis here. And in fact, you might even be able to see a bit of evidence here. So if you have a look around, can I get the lighting on it? Around there, roughly. It's actually really close up to the... in fact, you can see the line on the drive shaft where it just touches. So I probably need to shave that back a bit more. So if I go there, that little line there, that's where the left-hand side's just touching the drive shaft. So you can shave the... so which way does it go? Yeah, it does go that way. Shave this side down a lot, and then just very, very slow shave that down. Now, this is the drive shaft side, so it comes off this side. The servo that it comes with is 5-wire, so of course you're not going to be able to adapt it to your electronics. But dimension-wise, this is close enough. You can make up the difference with the longest screw into the drive, or whatever the drive arms. I'm really tired at the moment, so I'm not going to remember my terminology very well. Now the next part, and in fact I might do this live, is with how did I fabricate a servo horn. Now what I actually did with this was I just put the servo horn on the servo like that. I actually measured with a stick. I put the stick in, marked it with my finger, and then marked that to the top there, and then worked out where to cut. So what happened was, say the cut was there, I'd cut the servo down to that point, nice and easy. Make sure you hold the part off that you cut, because these plastics are actually quite brittle, and I tend to find they throw things across the room. In fact, I actually wear glasses when I'm doing this just to protect my eyes. So now there's an issue here. If you have a look at that bottom hole, I've definitely cut it too far. And any screw going in there is not going to work. But luckily in this case it's double-sided. So I'm going to cut it to the third hole. And then we'll go back into how I sized this all up. There we go. So cut it to the third hole there. And then what I did is I put the servo back in, and then I jiggled it left to right to make sure that A, the servo touched the bottom, and it wasn't being pushed up by this servo arm, and B, to see how much of a modification that I need in this arm. So if it wiggles a bit left to right, you've cut enough off, in which case you can swap over to a, what do I want here? I want the, there they go. Normally I'd use the half moon. Oh no, this one is even on the other side. And then I just went back and forward and took the edges off like that. And it doesn't take much, as you'll see in a second. It does require me to concentrate a bit, so I probably shouldn't be talking here, but... And as you can see, it like one side's been rounded off compared to the other. Now it will need to be fully rounded, and you may have to file a bit off the bottom itself just to get it to fit, but you just keep on putting them back in and going left to right until it actually does come up. And this is where you actually want the top part of the servo, because it makes it easy to move it left and right. And then once you've got it sitting in there and moving all the way to the left and right, what you actually need to do is enlarge one of these holes. Now the reason you have to enlarge it is, you may not need to on your servo horn, but on this servo horn it's used for very, very small and delicate screws, and those holes are tiny, whereas the screw I use is like nearly 3 times the size of that. I've luckily got some tools here. This is the Yare Racing screw kit, or hole making kit, or whatever you want to call it. So as you can see, comes with a whole lot of these little pieces. Now I actually used the largest one. I normally start off with a smaller one to enlarge the hole. And keep in mind this technique's not specific to the Carisma GT-24. Like I custom make my servo horns quite often, and this is just a technique I use. So you can see it cutting into the plastic. And don't go too hard, especially if you've got your finger underneath it. I have drilled into my finger just by hand, just by slipping, and it's very, very painful, and there's a lot of blood involved, so be careful. The other thing is, if you screw in like that and then pull it out, you may not have enlarged the hole correctly, so you actually have to put your finger underneath that and then just keep on drilling. Just to remove, if you just let it go in like that, it just produces like a spiral hole, and there still might be plastic on the side. Depending on what you're doing, that may be what you want, but in many cases it's not. If you want a clean hole, you have to go a bit further. So if we have a look at that. Now with this, I definitely don't recommend going off to the largest drill piece straight off the bat. That's where I ended up. But I actually did that by going through several intermediate steps. The reason for that is it's easier to keep everything centered, and you end up with a slightly cleaner hole. So, and you're less likely to make mistakes if you do it that way. So I'm just going to do it quickly if I can. Of course, under pressure, that's never going to happen. Yeah, like, probably you definitely want to be wearing gloves when doing this. It's really hard to understate how painful it is if you get one of these going into your finger because you slipped. There we go. Nice big clean hole. It's actually cleaner than it looks. There's just a bit of extra material left in there, so can I go through the back here? Probably not. Oh yeah. There you go, cleaned it up. Now, that's a bit dicey because I'd like there to be more plastic on there, but that's probably right at the limits of my comfort. Most of the forces are going to be side to side rather than up and down, so you might be able to get away with that, in which case it becomes purely for retaining the screw. So if you just put that away for a sec, because these are easy to lose. The other thing to watch out for is it's easy to snap these. So be careful, go slowly, don't apply too much pressure. Usual techniques will get you very, very far in life if you follow that. Okay, and I'm just wondering if I've got a screw laying around. Probably don't, but you never know. There's a scissors. Oh, I've only got micro screws available. But at this point it's relatively simple. There is actually one thing you do have to worry about, and that's why I chose not to use the closest hole. And that's when you put the screw in here, that the screw head doesn't impact this middle part of the plastic. I actually had to fabricate 2 servo horns purely because first time I put the screw in, it did touch across there, and I tried to file this down a bit, but it was still kinking up towards the center of the servo horn, so like that. Actually, I can probably demonstrate. So rather than being like that or parallel, yeah, it was kinked into the middle like that. Which is not bad. It worked, but it limited the amount of throw I had. And so I actually, once I fixed it, I ended up with a bit more throw. So it looks relatively straight. You can see it's actually kinked in slightly from that image there. And there, you can see it like it tilts up slightly towards there. But it was a lot better than it was previously. And then that screw gap was pretty easy. I just forced the screw in there and it held. And that's basically all the magic behind the electronics upgrade for the GT-24. Definitely worth it if you've got little parts laying around. These are all simple mods, so just need grease for the diffs. And I'm actually using a pretty aggressive grease in there, and they're still feeling a bit loose, which makes me wonder if some of the grease has actually come out. So I need to go off and have a look at that later. And even a slight bit of grease will make it a lot better in the corners. Then I put the neoprene in the diff, which worked nicely. Really easy to get off the shelf, and the other nice thing is you can get it in different thicknesses. I needed it for a separate project. It was very, very easy to just cut a circle and put it in there. There's better videos on YouTube on how to do that on the diff. There's not a lot of upgrade videos of the GT-24 I found, which was interesting. Then I put an ESC in and a receiver, and that's not hard. Just keep in mind that if you do replace a servo, you will be replacing the entire electronics suite. There's no getting around that. So it's very much an all or nothing approach. Now this is a low latency receiver. I haven't really noticed the difference. I've actually been pretty impressed with the Carisma GT-24 electronics to begin with. They have been pretty responsive, and the controller is actually pretty good. Bump that up a bit. And the ESC, that was a noticeable difference. I've got a bit, like the Carisma GT-24 gives you quite a bit of throttle control. This gives you significantly more and is a lot more configurable. With like turbo and boost modes and whatnot, which I don't really need. I just need all the power delivered all the time from 0, and I just need it to ramp up linearly in a linear fashion. If anything, I need more acceleration than I do need top speed. So the top speed definitely hasn't been affected, but yeah. So electronics all at once. I'm not going to touch the motor. If I did, I'd probably actually put something smaller in. The biggest issue when fitting everything in here is there's not a lot of room for electronics. As you can see, that's sort of angled and jimmied in. The biggest problem is that the plastic top doesn't leave you with a lot of room. So you have to work around that limitation. In fact, you've got more room up the back than you do up the front here, just due to the way it's shaped. So that's it. If you want more videos like this, let me know. I'm always looking for ideas, and this was a request by one of the users. I think it was Sammy Bucker requested this, so I was more than happy to oblige. As you probably saw at the beginning, I've got a second one, mainly because I really like this case. I didn't originally like this. I preferred the Subaru, which I've actually now got the Subaru as well. But I must admit that this has grown on me, and I actually think it's a better body. But now that I've got a stock and a modified, I do want to go off and see how they are different now. Like, you can only tell so much from the videos. And now I'll be able to do like an apples to apples comparison. And I do have some more minor mods for this plan, so we'll see how they go. I'll be doing the carbon fiber suspension towers because these flex quite a bit. There's a significant amount of flex in this chassis. I still don't know if that's good or bad, but I like my flex to be in very, very certain configurable places. Oh, and I should also mention I've grease filled the shocks, so I'll just do an example of that, and you should be able to see it quite easily. So you can see that it bounces like crazy, whereas this one it does bounce, but it bounces a lot less. So you end up being able to get back on the power earlier, and it's a lot more predictable because you've got your grip back. Awesome. Well, thanks for joining me, and I will see you all later. In the interim, keep on building, and have a good one.